Okay, let's try to answer this question together. Question says, given the below network routing graph with costs they're actually referring to these values here. These are the costs. Answer the following question that follows. So remember, these are nodes: node 1, 2, 3, 4, 5, and 6. So the first question says, list the path which the least cost when communicating from node N2 to N6, and how much is that cost. So the first thing that you're going to do, okay, I'm actually going to take a longer route. The method that I'm going to show you probably gonna take time, but just for you to understand, you can bypass some methods here if you quickly understand what's going on. So the first thing that you need to do is to, let me just write it down so that you understand what you know. We are answering number A. So the first thing that you need to do is to write down all the connections. Write down all the connections with their prices or cost. Let me just use the word cost. And how are you going to get these? You refer back to this. So let's create a table where we have, let me just do this table. I'm actually going to name this from and to. And then the cost, I just want you to understand, but you do not necessarily have to do this. See here, from 2 to 1, it's from 2 to 1, the cost is what? It's 1. And then from 2 to 3, the cost is 6. 2 to 3, the cost is 6. And then from 2 to 4, the cost is 6 as well. 2 to 4, the cost is 6. And then from what is 1? Okay, let me see. From 1 to 3, the cost is 7. Can I have that? 1 to 3, the cost is 7. And then from which one can I pick? From 1 to 4, the cost is 3. 1 to 4, the cost is 3. And then 1 to 5, the cost is 3 again. 1 to 5, the cost is 3. And then let's see another one. From 5 to 6, the cost is, it's 3. The cost is 3. 5 to 6, the cost is 3. Then another one. Which one did we leave? We did this. We did that. Okay. 4 to 6, the cost is 2. 4 to 6, the cost is 2. And then let me check another one. Which one did we leave? Did we do everything? Or 3 to 4, the cost is 2 as well. 3 to 4. Doesn't matter which one you choose. You can either take from 4 to 3 or still the same. Okay, this is what you have here. So the following step that you are going to do, you're going to try all the possible paths from N2. You don't really necessarily to do so if you have a quick eye, but for you to understand, we need to understand what's going on. So let me just write step number 2. You're going to try out all possible paths from N2 to N6. And this is from the question. The question itself says, list the path with the least cost when communicating from node 2 to 6, and how much is that cost. You see, here it is. Oh, we actually have to list the path. Okay, it's fine. But you see, from node 2 to node 6, see, from node 2 to node 6, but we need to use these paths. For example, let's start here. I can see this path, it's 2 3 4 6. Another one is 2 2 3 4 6. Another one is 2 4 6. Another one is 2 1 5 6. Another one is I think that's it. So let's start with let me just write it down. Let's start with 2, then 1, this route. Okay, 2, let's start with 2 1 5 6. So let me just copy this so that I'm able to remember what's actually going on. So to make it simple for me, let me just do this. I don't want to waste time. From 2 to 1, it's 1, this 1. Then from 1 to 5, 3, this 3. Then 5 to 6, another 3. Let me just copy this thing the way it is. Cut, it's fine. Let me just cut it. You see, there was no need for you to do all this, but all this, I just did it so that you understand how the node from, to, and the cost. Okay, try out all the possible. Let's start with the one that I just copied here. Paste. If we paste this is the first path. Let me just call this the path 1. I'll just say P1 for the path 1. If you add this, it's going to give you, if you add this, it's going to give you, what is it? If you add the 1 plus 3 plus 3, it's going to give you 7. Now let's go and pick another route. We've already done this. Let me change color for another one. Let me erase this. Okay, let's use red for another one. From 2 to 6, let's take 2 4 6 and 2 4 6. So the values between it's 6 and 2. So it's going to be 6. Let me first erase 6 plus 2. Cut this. Let me call this P2. So 6 plus is going to give you 8. Remember, we're calculating the cost. These are the costs. We're adding the cost. This is 8. And then we go look for another route that we can use. Let me change the color to another color. Let me try green. Okay. From 2 3 4 and 6. So it's 2 3 4 6, and here from 2 to 3 we have, can I use blue? Let me use blue. We have 6 plus, from 3 to 4 we have 2. From 4 to 6 we have 2. Let me take this, cut. So let me call this P3. So 2 plus 2, this is equal to 10. This is equal to 10. Now let's choose another route. all possible routes. Let's check another one. Let me choose another color. Which color can I use? Okay, let me use this. I don't know if you'll be able to see this color, but I'm out of. Okay, let's from 2 to which other route can we use? 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 Let's think. We can use 2, 1. Oh, we can use 2, 1, 4, 6. So it's 2, 1, 4, 6. And let me use the color blue. From 2 to 1, we have 1. From 1 to 4, we have 3. And then from 4 to 6, we have 2. Copy. Oh, sorry. Cut. Let me name this P4. It's going to be 4 plus 6. This is going to be 6. And come back again. We'll look for another route if there's another possible route. Let's see. Which color should I use now? These colors. I'll use this. Let me try to use this one. Another possible route is 2, 3, 4, 6. Yeah, that's all. You cannot use that's all. That's what I see at the moment. It's 2. Okay, that's 2, 1, 3, 4, 6. Change to blue. From 2 to 1, I have 1. From 1 to 3, 7. From 3 to 4, I have 2. From 4 to 6, I have 2. This is already, you can see from here, no way, this is not going to be the least. But anyway, let's just continue calculating. It's fine. This one is going to give us 12 if we add these values. Because remember, the question says with the least cost communicating from N3. So it's fine. I'll just show everything. But I think if I was the one answering this question in an exam, I wouldn't go to this extent. The moment I realized that this value is going to be huge compared to the one that I've already calculated, I think I was just gonna miss it. But anyways, let me just do it. P5, paste this here, saying this is going to be 12. Already this is out of the question. Another route, is there another route that we can try to find here? Okay, let's say we found all the routes, and for the sake of the length of the video, let's say we've got all the routes. So we've already calculated the total. So from here, you choose the route with the least cost. The least cost, this is 7, this is 8, 10, 6, and 12. Obviously, this is our route with the least. So it's going to be, you're going to write, the last step is going to write the actual path. And here's the answer. Let me just choose which color, the red color. I like red. I feel like red shows correctness. It's okay. Okay, so it's from N2, N1, N4, N6. This is the path. The total cost is 6. And just like that, you've answered number A. Now let's go to this other question, which says, given the local, question B, given the local datagram forwarding table for node N2 above, and the destination address, which is, here's the destination address. It is written in dotted decimal. Yeah, I think that's correct. Dotted decimal. All right. So, okay. The first thing that you need to do, is to convert this to decimal. So let me do this. Let me just write it down here so that I copy it down there. Let me use which color? The black color. It's 231.129.61.190. Let me cut this, paste it here. Okay, we are answering number B. So I will just write the binary down because I've already calculated this binary. So I'll just write them down. And if you want to learn how to convert these dotted value to binary, there's a video that I made. Check my videos there. I think you'll find I know you will find a video which shows how to convert this to binary. So this 231, it's going to be 111 0 0 1 1 1. Then this one 29, it's going to be 10 0 0 0. Let me see, 1 2 3 4 0 0 1. Then this one 6 1, it's going to be 0 0 1 1 1 1 0 1. Then the other one is going to be 1 0. It's going to be 0 1 1 1 1. And then let me see, 5 5 here, 0. Just like this. So the full binary is going to be copy. Let me just paste it here. Okay, this is the full binary. Let me just say full binary. These represent this in binary format. This is in dotted decimal. This is in dotted decimal. This is still the same thing. So what you're going to do next is you go back to this table. You see on this table, you compare. Here you just actually compare which one does it matches with. Which one does it actually matches with here. See this. So, pay attention to this. You see this, what do they call this? This is asterisk or what? Yeah, this values here. You try to come and check which one is the closest to this what you have here. For example, let me just give you an example. Sorry, you try to check which one it's, I don't know, can I put this in a very check this one, check this. I don't know if I was using that correct term, closest. I actually wanted to say which one is exactly, your English is which one is fits with this, or when you compare the destination address ranges is exactly the same with. So you see, check here. Let's check our last octet. So this is where you're going to check. You're going to check this value here. Ours starts with, it's 10 11. If we come and check here, we do not have any, okay, we have one which says 10 11. Fine, we do have this one. You see, this one is already out. Take this one out because ours says 10 11 already out. This one 10 11 and this one 10 11. Now we need to check what is our saying. 10 11 and then 10 11, then another one follows. So okay, this one is already out. We're left with this. Now we need to confirm if this is correct. This one, there's a following 0 there, but if you check on ours, we have another following 1, so it's not the same. Now you go back to your table. Your table says if it's not the same, otherwise it should be, the output link interface should be 1. So your answer is going to be what? It's going, the packet does not match any of the first three ranges, so it should be forwarded to N1. So the answer is forwarded to N1. Forwarded to N1. Thank you.